My name is Javier Guillén and I'll be working on chapter 5. So, naming acids. First, I'm going to start with um, acids that do not contain oxygen, and they usually start with an H, which stands for hydrogen. If it's hydro, it means no oxygen. First, we have an example for HF, which stands for hydrofluoric acid. Hydrofluoric acid. The suffix it's added to the compound, to the acid. Another example, we have HI, which stands for hydroiodic acid. Now I'm going to be working with onions that contain oxygen. For this example, have HNO3. The O is telling us that it contains oxygen. So the name for this one will be nitric acid. Here we have HNO2. This will be nitrous acid. Another example will be HC2H3O2, which once again is telling us that it's oxygen. So these ones will be acetic acid. Working with D block, we need to use the Roman numerals to indicate the charge. For example, we have F3 plus, which translate to iron 3. Another example of Cu plus, which translate to copper 1, which is this one. The third, move to that. Okay, another example, we have SN4 plus, which translate to 10 4. Once again, this translates to charge. Another example we have, it's with vanadium 3 with phosphorus 5. To identify or to find the value of vanadium, we need to first solve for V. So we know vanadium is 3, and phosphorus is P, well, basically 5P, so it's plus 5P, and this is how we set the equation. Okay, then 3 vanadium plus 5, and we know for phosphorus it has a -3, so we keep working the problem to equal it to 0. We have V plus -15 equals 0. 3V plus then we add 15 to both sides. We have dV equals 15, and then we isolate a vanadium. We have vanadium divided by 3 have vanadium equals 5. So the final formula will be vanadium to identify the charge, which is 5, phosphate. Another example from that D block using Roman numerals to identify it will be SN3E04. Okay, we know the phosphorus has a 3, so we need to solve SN plus 4. This is how we translate equal to 0, okay, because of then we 3 N plus is -12 equals 0, and then we add 12 to both sides, so we have 3N equals 12 divided by 3, CSA is 10, M equals divided by 3 equals 4. So the final equation will be, formula will be 10 4 phosphate so for polyatomic anions, we have calcium sulfide, we have calcium, and we have sulfide. And for this one, calcium has a positive charge of 2 and sulfur has a negative charge of 2. So they cancel each other, so we simply call it CaS for calcium sulfide. Another similar example, from another example for the polyatomic ions, we can simply have magnesium bromide, with magnesium having a positive charge of 2 and bromide having a negative charge of 2. In this situation, we want to crisscross. So magnesium takes the -1 and bromide takes the 2. Since we only have a 1, we don't have to write it down, so this will be our final formula. Okay, so we can just simplify it, like Br2, forgot the R. Okay, so another example, we have sodium sulfide. We know that sodium has a positive charge of 1, sulfide has a negative charge. So the same method, we're gonna crisscross. We have sodium 2, sulfide 1, but since we only have 1 here, we don't have to write it down, so this will be final formula. So for examples of covalent molecular ionic metal and non-metal compounds, we have so for this one we need to use the prefixes. So we have nitrogen, we have the O3 with oxide, so we have two nitrogens, so we have D nitrogen, and then we have three oxides, so we have D nitrogen trioxide. So this indicates we have 3, and this one indicates that we have 2. For another example, we have P4S10. So for P, we have phosphorus, and for S we have sulfur. Now we have CF4, so we have carbon and fluoride. So we have 4, so we have tetra, which is the prefix for 4. So we have carbon tetrafluoride. Carbon, we don't use mono, which means 1, just leave it like that. One as example, what I use here is ClO7. First we have chlorine, and then we have oxide, for the 7 we have hepta, for the 2 we use D. So we'd use for chlorine we have dichlorine and heptoxide.